Welcome everybody to this webinar titled FIPS 140-2 Validated Encryption for Windows Containers. My name is Kevin Ng. I will be your host and presenter for today, and I am a Senior Solutions Architect here at Mirantis. For over a decade, I've been delivering DevOps strategies to Fortune 500 companies across diverse sectors, including finance, retail, healthcare, logistics, and consumer goods. And on top of that, really evangelizing the benefits of containerization, Kubernetes, and DevSecOps practices. So I aim to empower organizations with the knowledge and tools they need for digital excellence through webinars, such as this one. And customers we work with have seen up to 90% reduction in their application delivery time and deployment fail rates, as well as increased deployment frequency by over 10 times. And this has led to increased customer satisfaction and ensured robust performance during critical high volume periods, such as Black Friday that's coming up or Boxing Day.
Need to learn Kubernetes quickly? Check out our free ebook with hands-on exercises you can complete on your laptop over a short break or lunch. Visit mirantis.com/learnkates to download now.
In today's webinar, we will talk about why proper encryption is so important for container runtimes. What are the fundamentals of FIPS 140-2 validation? We'll also discuss the landscape of container tools on Windows environments and how to use the FIPS 140-2 validated runtime on a Windows node in a Kubernetes cluster. So for those of you that are not just doing containerization and are actually orchestrating through Kubernetes, we'll talk about that as well. So the first thing I want to cover really is, why is proper encryption important for container runtimes? In order to answer the question, I'd like to dispel a few common myths that surround containerization. Containers are completely isolated from the host. And folks may think, okay, yeah, with containers, we take a number of the file systems that is required for your container run, all that, we package it up into one image, and we deploy it. Whereas in reality, while containers do offer a degree of isolation, they're not entirely isolated from the host system. And we actually see how that, why that's the case. Because if you look at this, if you look at how containers operate in comparison to virtual machines, right? So we have our virtual machines over here are each individual VM running on hypervisor on top of the infrastructure. And then when we look at our containers, we have our individual containers running on top of the container image on the operating system, right? So you see over here, containers, or the container engine itself, I should say, actually sits directly within the operating system. And therefore, as a result, the container shares the host kernel. And if a container is compromised, especially one of those with high privileges, there is a potential risk to the host or other containers as well. Now, of course, there are tools and controls we could apply to the host operating system in order to mitigate some of those risks. And that's true for both Linux and Windows, right? So with similar functionality, but differing principles. We can look into it and let's see how that affects then our container security, right, in terms of container runtime. So let's start with the Linux side of things. On Linux, the ones that are usually talked about are one of the two things, right? One, seccomp, which is your secure computing mode on the left over here, is a security mechanism that restricts system calls that applications can make, right? So we're working on a system call layer. So it operates on a very low level, allowing granular control over the system resources an application can access. So it can filter system calls, reducing the kernel's attack surface, essentially. The seccomp is pretty specific in its scope, and it's used really for fine-grained control over application permissions at this kernel level. And when you take it a level higher, right, coupled with that, we have AppArmor on the right over here. So AppArmor is more of an application security framework that provides mandatory access control for programs. So in terms of functionality, it enforces security profiles for individual applications, and it controls which files and capabilities a program can access. So it's on a higher level versus seccomp, where seccomp is more granular on the lower level side of things. So AppArmor is used really for defining application level policies, and it's more focused on what an application can access rather than what it can do. So like I said, files access in terms of capabilities, right? And then what it can do is really more the domain of seccomps. And you can see how it's being set up over here. You're able to allow folks to make directories or not make directories, whereas over here, you're saying which files can be accessed or not accessed. And when we look at the Windows side of things, Windows do have comparable functionality as well, right? So we start off with the Windows attack surface reduction or ASR rules, and which is kind of, we can think of it as the seccomp equivalent in Windows. So the ASR rules is part of the Windows Defender and is designed to reduce the attack surface, again, of applications, preventing actions that are commonly used by malware. So you see over here, there are some activities that you can do or cannot do that can be controlled using ASR, right? So ASR provides a set of controls that can block potentially malicious behaviors, such as the execution of suspicious scripts, attempts to maliciously encrypt files, or untrusted and unsigned processes. If you look at the scope of ASR, though, ASR rules are more about behavior blocking and less about granular control of individual application and processes. And that's where it kind of differs from seccomp a little bit. Whereas seccomp talks about really like the proper system calls that can be made, ASR is more about the behavior side of things and what it can and cannot do. And you could start, when we start talking about this a little bit more, you start seeing the common theme of how Windows security operates versus Linux security. And we'll talk about the comparisons in a minute as well. On the other side, we have our Windows Defender Application Control, or WDAC for short. And this is kind of our Windows AppArmor equivalent. WDAC is designed to restrict which applications can run and which code can be executed by those applications. So it can be configured to allow only trusted applications to run, enforcing code integrity policies and ensuring that only signed scripts and libraries are loaded. And that's the important thing to note, because if you notice, it's talking about trusted applications, it's talking about code integrity, it's talking about signed scripts. And that's something slightly different to AppArmor as well, right? So, it is comparable in the sense that it's an application whitelisting tool. And it focuses on ensuring that only authorized code can run on a system. But when you compare and contrast the Linux versus Windows approach to security, AppArmor and WDAC both have a similar philosophy in controlling which applications can run and which resources they can access. But when you look at the Linux approach, it's more about permissions and access, right, of the individual items. Whereas in Windows, it's more about the integrity, code signing, code integrity, and the origin of applications. And when you even break it down further, when you look at the granularity of controls, seccomp offers very granular controls at the system call level. Whereas the ASR rules that we have over here is more about general behaviors and patterns. WDAC here provides application level control, similar to AppArmor, but it focuses more on application integrity, right, and origin rather than on the file system itself and network access. And you notice I'm kind of belaboring the point a little bit because you see how the focus on integrity of origin, though, could potentially still pose a risk to Windows users. Because what we're doing here was we're checking that the files are coming from who they propose to come from, or who they claim to have come from, and that's through signing. But when you think back, think about the March-April timeframe this year, Western Digital actually experienced a hacking event where, according to the reports, the hacker actually shared a file that was digitally signed with Western Digital's code signing certificate, which means they can now digitally sign files to impersonate Western Digital. And as a result, then, potentially bypassing WDAC restrictions because it is the integrity is there. It's the right signing agency. It's the right source, but it's coming from a malicious actor, right? So as far as the system is concerned, any code that the hacker runs, malicious or not, are certified code because they have the digital signing certificate. So that's a problem. And therefore, we need to make sure that, obviously it doesn't get breached in the first place, but even if it does get breached, that information does not get pulled off from your sources through encryption. Now, myth number 2, that containers are secure by default. And folks may think that because, containers are relatively small units of work. They should have inbuilt security to a certain extent, and they're somewhat isolated, which we kind of debunked in the previous myth. But in reality, the default settings for containers may not be all that secure. For instance, most Docker containers, if not correctly configured, can run with elevated privileges. That's why we have rootless mode on the Mirantis Secure Registry and the Mirantis Container Runtime, right? And this could lead to security vulnerabilities, particularly if an attacker gains access to a container. Now, let's look back at our container ecosystem, right? If we look at this, By default, container images are not encrypted, and as a result, it makes it easier for the attackers to, one, access sensitive data, because without encryption, data at rest or in transit within the container can be more easily intercepted or accessed by unauthorized parties. And without a secure credentials management system, in order for the application to work, the sensitive data kind of has to live on the container, right? So your things such as your private keys, your API keys, they're often stored within the containers. And number two, if the container has unpatched vulnerabilities or misconfigurations, attackers can exploit those to gain access or escalate privileges, and thereby giving them the ability to execute malicious code and or commands within the container. A simple Google search will give you a number of tutorials out there showing you how to encrypt a container image using things like OpenSSH and RSA keys and etc. And that's all good. So we go ahead and encrypt our container images, yay. And we think it's safe, yes. But now, here's the problem. While the images are perhaps encrypted, the thing that it is running on isn't, right? And since they're not encrypted, the data and processes within the unencrypted area and within the container runtime, they're still exposed. And that opens up a pathway to the host system for attackers to potentially access or manipulate the container's data. They can also perform things such as network eavesdropping to capture sensitive data being transmitted to or from the container over the network. And that's not good. So now that we know the importance of encrypting the container runtime, how do I know if the encryption is safe enough? But the good thing about this is the work is already done for you. And we will point to the National Institute of Standards and Technology, or NIST for short. They're basically an agency of the US Department of Commerce that publishes and manages several important standards and guides, such as the definition of cloud computing, zero trust architecture, and our target for today, FIPS 140-2, which outlines the security requirements for cryptographic modules. When we break FIPS 140-2 down, there are a couple different levels, and here's a warning, there are plenty of acronyms coming up. So when we talk about FIPS, FIPS stands for the Federal Information Processing Standards. They are a set of standards and guidelines for federal computer systems that are developed by NIST, and we'll talk about NIST in a second as well. Well, we have talked about them. So they're developed by NIST in accordance with the Federal Information Security Management Act, or FISMA for short, and they're approved by the Secretary of Commerce. No acronyms in that one. So essentially, if you think about this, NIST develops FIPS standards, one of which is the security levels for 140-2. Okay, so your cryptographic security modules. So FIPS 140-2 is a standard that handles cryptographic modules and the ones that organizations use to encrypt data at rest and data in motion. Okay, so FIPS 140-2 has 4 different levels of security, with one providing the component level security and level 4 being a fully hardened system. And when we typically look at individual components, you'll be looking at level 1 and level 2 security, there and thereabouts. Right? So when you look at level 1, a level 1 security is a software-based cryptographic modules running on a general purpose operating system such as Windows or Linux. And that's basically a level 1 FIPS guideline, right? It doesn't require physical security mechanisms, but it must implement basic cryptographic functionalities correctly. Now, when you go into level 2, a level 2 is more like a hardware security module, HSM, that includes tamper evident seals that requires a password or PIN. So if someone attempts to physically access the module, the tamper evidence seals would show signs of interference. Now, when you're looking at the software-based implementation, you will look at things such as role-based authentication, right? Role-based access control, so RBAC and things like that. And that's required at this level. I actually go into FIPS levels in more detail in an earlier webinar. So if you're interested in finding more about those levels, it's available both on demand in Bright Talk and also on the Mirantis YouTube channel. So I encourage you all to go watch that if you're interested in the background there. And when you think about this, why does FIPS actually matter? I mean, who needs this? Who's using this? Why is it doesn't apply to our industry, my business, right? So, I mean, at the first level, obviously all North American government agencies and facilities, or those working with government agencies. We have a number of customers in the federal space that actually do need to apply this because of, it's a federal mandate, right? And by extension, our customers that are working with government agencies or potentially have customers that are in the federal space will also need to have these applied, right? So, it also it's also referred to, I should say, within other standards such as FedRAMP for cloud applications, the STIG, again, for federal implementations, PCI DSS for payment, and we'll talk about those in the following slides as well. But on top of that, then you can also see that regulated industries such as your finance, your telco, and healthcare would benefit from this, right? Especially when you're in finance, you have your payment information. With healthcare, if you're in North America, you have your HIPAA laws of making sure that data in transit and at rest is secure so that you're not violating any data privacy laws. And that actually does help as well with GDPR rules because, again, it helps with the data integrity and privacy, protecting sensitive data, right? So essentially, any industry that needs encryption to protect sensitive data, the payment card industry, all that, this will actually apply. And if we dive a bit deeper, let's start with FedRAMP. Now, FedRAMP 5 has just been released not long ago, right? And if you look through the FedRAMP rules, actually, it refers to FIPS 140 in a number of different places, right? In your transmission confidentiality and integrity, it uses FIPS as the encryption mechanism. Your cryptographic protection is the same thing. It uses FIPS 140 as the encryption mechanism, and also protection of information at rest. So all these actually refer to FIPS 140 standards, right? So having that in your container runtime, and by extension, then you actually don't have to worry about that within your own product stack if you need to, let's say, for example, adhere to FedRAMP standards, right? And we've actually helped the customer do this as well. So Netscope is one of our customers that is using the Mirantis OpenStack on Kubernetes platform that we provide. So what that is essentially it's OpenStack virtualization platform. We've containerized it and it runs on top of the Mirantis Kubernetes engine, which is based on top of the Mirantis Container Runtime. So our Container Runtime has the Kubernetes orchestration on top of that, and we have OpenStack to deploy virtual resources on top of that as well. And through our customized resource solution, they were able to achieve FedRAMP high authorization to operate, so high ATO. So that's some of the things that we actually are able to assist with folks as well. Now, on top of FedRAMP, there's also the other side of things, which is the DISA STIG, right? And that DISA stands for the Defense Information System Agency, right? Defense Information Systems Agency. Some call it DISA, DISA. It's up to you. And then the STIG stands for the Secure Technical Implementation Guide. So you may hear it referred to as a DISA STIG or just STIG for short. So a STIG essentially describes how to minimize network-based attacks and prevent system access when the attacker is interfacing with the system. So either physically at the machine or over a network, and based on the Department of Defense policy and security controls. Now, STIG also describes maintenance processes such as software updates and vulnerability patching. And as you can see on the screen over here, if you're using Windows Server 2019, here's the entry for the STIG implementation of Windows Server 2019 on how it must be configured using a FIPS compliant algorithm. And if you look at the rule ID and do a search on that, you actually find this along with the steps on actually implementing it. And we'll talk about this in a second as well. And it's the same set of standards used in the PCI hardware security module as well. You can see over here on the PCI DSS rules, key encryption you'll require HSMs that comply with FIPS 140-2, right? And all that would meet any PCI DSS requirements. So it's the same set of standards being applied in different contexts, right? So you see how it's actually important across all industries and all different horizontals and verticals. Now, when we talk about FIPS, FIPS essentially gives us a validated encryption algorithm to use within our systems, right? And when it comes to FIPS, the word validated is actually quite important. You may come across folks that say, yeah, we're FIPS compliant, or you've got the folks that say we're FIPS validated, right? And they mean different things. When someone is FIPS compliant, that means, yeah, our software is built using FIPS guidelines. They've gone through the FIPS requirements and we built it, or perhaps parts of the software is FIPS validated. But in order to properly claim that the software or component is FIPS validated, that means the software must be reviewed, tested, and approved by a NIST-approved testing lab. And the validation process is actually a pretty involved process. If you look at the actual process, you start off with the cryptographic module vendor, in this case, perhaps like Mirantis, or who's providing the runtime, or our vendors, perhaps, in terms of the build pipeline. If they claim to be a FIPS validated vendor, this is where things start off, right? So we start off by taking our results and we submit it to an accredited lab for testing. The lab would then provide the test reports back to NIST and CSC, and then a bit of back and forth. And once everything is good, the vendor, us, we get a certificate, and it's also published into a list of validated FIPS 140-2 modules. So it's actually public information for everybody to see. So if you want to check whether your vendor is FIPS validated, you could always go up to the CMVP program to look at the actual certification, right? So over here, to verify that the software is NIST certified, you go on to the Cryptographic Module Validation Program, the CMVP, and the website actually gives us all of the different vendors and all the different components that are validated, and as long as with the security as well. So if you scan this QR code, you will see the Mirantis Cryptographic Module Certificate stating that we are actually FIPS 140-2 validated by NIST and their labs. Now, when you think about the Windows environment, then, which is perhaps why you're interested in the first place and why you're here, what are some of the options of container runtimes on Windows, right? You got to run your Windows workloads in a container. You need your Windows kernels. Therefore, you need a runtime that supports it. Now, if we look at our options, according to Microsoft, there are only 3 container runtimes that supports Windows containers. There is the Mirantis Container Runtime, MCR for short, the Moby project, which is the open source upstream of the Mirantis Container Runtime. And we actually do have a number of maintainers in the Moby project as well. So our groups over here. And there's also the open source container D, right? And of the 3, the Mirantis Container Runtime is the only container runtime with FIPS 140-2 validation, providing the security benefits and the peace of mind. Remember back to the STIG implementation, we're looking at how do you make sure that Windows is running in FIPS mode, and also your container runtime is running in FIPS mode. It's actually pretty straightforward. So enabling FIPS mode on Windows is really a simple configuration change. And the steps are outlined on the Windows 2019 STIG with the rule number that was shown earlier. So the first thing you do is go into your local security policy, SecPol, the MSC, and you look for your local security options. And there's an entry in there that says use FIPS compliant algorithms for encryption, hashing, and signing. Now, by default, it is probably going to be disabled. So all you do is just double click on that and hit enable. And what that would do as well is if you have Mirantis Container Runtime running on top of Windows, it'll automatically set everything into FIPS mode. So your Windows is in FIPS mode, and your container runtime by default will also automatically run into FIPS mode. And you could verify that by running a simple Docker info and look for the label Docker security FIPS, and it will be enabled once you turn on the FIPS mode. So it's pretty simple. You don't have to jump through multiple hoops to make sure that your container runtime is safe. It's running in FIPS encryption. So why not do it, right? It's a simple activity to do, and the peace of mind that you get from that is it's priceless, right? So now that we have the container runtime ready, our container node is good, but what if we want to include it into our orchestration, right? So when it comes to connecting your Windows container workloads to Kubernetes cluster, it's actually pretty straightforward. MCR makes it really easy to manage both Windows and Linux nodes within the same cluster. Essentially what will happen is your Windows application code will deploy onto the Mirantis Container Runtime on Windows or Linux, and basically it's the same runtime on both of these, and it could connect to any CNCF certified Kubernetes distributions. Now, of course, if you utilize the Mirantis Kubernetes engine, which is also FIPS 140-2 validated, It supports both Swarm and Kubernetes orchestration, and the Mirantis Container Runtime is already included out of the box. Now, the way that the Mirantis Container Runtime works on any Kubernetes distribution is through CRI Docker D. So regardless of what Kubernetes distribution you use, as long as it is CNCF certified, it'll interact the exact same way. So when the kubelet needs to execute or run a pod, it communicates with CRI Docker D, and then the CRI commands, then it gets translated into Docker commands, which allows Kubernetes to interact with MCR just like it would any other CRI compatible runtime. Now, to learn more about the history and workings of CRI Docker D, watch my webinar on the Mirantis YouTube channel on how CRI Docker D standardizes container workflows on Kubernetes. We actually go in much deeper on how CRI Docker D came about, how it works, where it's actually maintained. Throughout today's webinar, we've debunked a number of container security myths. We looked at how FIPS relates to other security standards and reviewed how you could have the same enterprise-grade secure runtime for your Windows workload as well as your Linux workloads working in any flavor of Kubernetes. In addition, with the Mirantis Container Runtime, you will have security through isolation, and it's also FIPS 140-2 validated. You're running on open standards, open source standards. You also have the stability and predictability of an enterprise-grade container runtime, because we do run this through extensive testing on different scenarios and operating systems. You also get abstraction through standard API and execution on multiple operating systems. And the Mirantis Container Runtime is a component of the Mirantis ZeroOps portfolio, which covers all activities from run, deploy, visualize, and secure. To learn more about the portfolio, I invite you to visit our website at www.mirantis.com, where you can actually find documentation. There are plenty of customer case studies, there are blogs and white papers, and also you can sign up for a free trial of the FIPS 140-2 validated Mirantis Container Runtime for both your Windows and Linux workloads. Well, it's been a pleasure to share this information with you. Feel free to reach out to me on LinkedIn or via email if you'd like to discuss your environments or anything you hear in this webinar any further. And do please make sure to check out our website at www.mirantis.com and test run it for yourself. I look forward to seeing you in future webinars, and have a good day.